Okay.
All right, good.
The red dot's not even on the screen.
Yes, it is. It's right there.
Aiming
It's
at
right in the middle. I'm gonna do my acid next.
All right, so if you look at any acid, every acid is going to have an anion and then a certain number of hydrogens to go with it. So the name for the acid is based on the anions. That makes sense, right? So there's basically three possibilities that you can see, right? You can see IDE, you can see OUS, oops, nope, sorry, I'll write that. You can see ITE, and you can see ATE. So this would be like chloride or fluoride. Basically any element by itself is going to have IDE at the end when it becomes an ion. Oxide, sulfide, and so on. ITE and ATE are polyatomics. Sulfite, sulfate, nitrite, nitrate, same. Alright, so based on which one of those endings there are, that tells you how to name it and the name of the particular ion. So there's three rules. One, if the anion ends with IDE, right, hydro. So it's going to start with hydro at the beginning of the name.
Always.
Then the anion, but change the ending to IC.
Why?
That's just a rule.
That's a rule?
Yeah. So any acid that has an anion in it that has ID at the end of its name, this is how we name that acid. Oh, and then you always write acid at the end. So acid. So, you know, scientists can be boring and redundant sometimes. Every acid has acid in the name. So let's take an example here. Let's say we have HF. Okay? So you look at F, what's F?
Fluoride?
Right, it's fluorine, but when it's an ion, we call it fluoride, right? So, fluoride. So this one, since it has ID at the end, we're going to start with hydro. The name will begin with hydro. And then you take fluoride and throw out the IDE and put IC instead. Fluoric. And then you name it all
acid.
acid, that's right. That's it. The same HCl is hydrochloric acid, HBr is hydrobromic acid, and so on and so forth. All right. Rule number 2. If anion ends with ITE, no hydro at the beginning at all, just write the name of the anion. And I should keep writing here. And change the ending to OUS. And then, of course, write acid at the end. All right, so for this one, Let's see, what if we have, what am I gonna use here? Yeah, let's do that. Alright, so this one would be H2SO3, let's do that. Alright, so what's SO3? Sulfite, yeah, that's on page 257, right? That list I want you guys to memorize. Sulfite. I'll just come back. There it is. So what we're going to do is we're going to change the ending here from sulfite. Acid. OUS, right? So that one sounds kind of funny. Another example, that's what it is, it's kind of weird. Let's do HNO2. What's this one? What's the anion called?
Nitrate.
Close?
Nitrite.
Nitrite, yeah. NO3 is nitrate, NO2 is nitrite. Nitrite. So we take the ending of that off and we call it, what's this going to be called? Nitrous acid.
Is that what they call it, nitrous for like cars?
Yeah, it's a different thing, but yeah. It's very simple. I think so, anyway. It means the ballpark. Alright, what that right here? One more rule. I have to erase somewhere. Let me erase it here. So, 3.
These furniture, you can actually see like the words from the camera. Like when you videotape, you can actually see the word pretty good.
I don't know, can you?
Yes.
Yeah?
Yeah.
Half is cut off by this school.
Nothing.
What is it?
Half is cut off by this school.
Nothing is cut off. It's
Oh.
fine.
If, oh, my stuff's upside down. If anion ends with, what am I doing? ATE, right? The only choice left, ATE. Right. Name. Change the ending to ic. And then, of course, write acid at the end. So we're using IC again, except this time there's no hydro at the beginning. So, let's see. We can go with a couple examples here. HNO3. What's NO3 called? Nitrate. I don't want to go too far over that way. Nitrate. You just throw out the ATE, you put nitrate acid. Sulfate, sulfuric acid, acetate, acetic acid, and so on. You good with this? Alright. Now, you want me to do any more examples because I gotta do something else before I finish? Okay. Alright. Does everybody have this written down? Alright. Now we also gotta be able to do the reverse. So if I give you the name of an acid, I want you to also be able to write the formula. So that was naming. Now this is writing formula. And really, I'm going to write these couple rules down, but this is stuff that, you know, if you remember everything we learned in this class, you kind of know how to do this, but, you know, probably worthwhile to go over it. So, rule number 1, use naming rules to figure out the anion. So you gotta be, look over your rules and be careful. If you see hydro, that means the anion is gonna be a single element. If you don't see hydro, then the anion is gonna be a polyatomic. So if you see OUS at the end, that means it ends with ITE. If you see IC, it ends with ATE. Right? So let's look at an example here. If I said phosphoric acid. Okay? Phosphoric acid. So what would the anion be in that?
Phosphate.
Phosphate, right? It has ic at the end, but it doesn't have hydro at the beginning. That has to end with ATE. So the anion must be phosphate. Okay, so that's step one there. 2, find the charge of the anion. Well, that's easy. You just look it up, right? I mean, if it's on the periodic table, you just look at what group it's in. If it's polyatomic, you just look it up on page 257 and tell me what the charge is. What is the charge? It's only a few numbers, right? Just guess a few. It's -3. Phosphate's -3. So PO4 -3. You find that on page 257. Did I mention that there's polyatomics on page 257 are important? Rule number 3, add enough hydrogens it means H plus, right? To make the charge 0. So how many hydrogens is phosphate going to need to get down to 0? Or up to 0, depending on the direction. Come on, no, say it. Come on, boy. Say it. Say it.
3.
Thank you. Good job. Clearly she was embarrassed to say it. So yeah, it's got a -3 charge, right? And if the hydrogen is +1, then you need 3 hydrogens. It's got to be H3PO4. That's phosphoric acid. Let's do one more if I can find some space here. All right, let's not do sulfuric acid because you probably know that one. Let's do hydroiodic acid. I know it's a strange name. All right, step 1 is going to be, what is the anion? Iodide, right? Iodide. Iodide or iodine. Oops. Can't spell that. Yeah, since it's an ion, we'll call it iodide, right? But it's iodine from periodic table. So. Okay. What is the charge of an iodide ion?
2.
Just guess, right? It's 1, 2, or 3. Wait till I tell you the answer. What is it? It's -1. Why is it -1? Yes, if you look at the periodic table, it's in group 17, right? Everything in group 17 has a -1 charge. You should have that written on that periodic table I gave you guys. So iodine is -1, right? We just put minus, it's -1. All right, so how many hydrogens does it need? 1. So the formula is just going to be HI. Questions? You good?
Just changing it, you just take away the IC.
Yeah, when you're naming them?
Yeah.
Yeah. You so yeah, going from this to this, you just take away the IC, it becomes IDE. Yeah. What else?
All of these on page 257 to find out the charge.
Or the periodic table, right? The single ones are on the periodic table. All the other ones are on 257. Alrighty. So the first part of the worksheet, you'll name them. The second part, you'll figure out the formula from the name. the honors.
Yeah.
Yeah, apparently there was a text message just sent